All right, so we're graphing sine, cosine, and tangent today. Basically, you're looking at three graphs, and you're just going to learn about their shape and what happens with them. Okay. Muy importante that you understand the shape of these graphs, okay, especially for your project. Tomorrow, I'm going to show you how to stretch them vertically, okay, and expand or contract them like a spring horizontally. It's very important for music. The next day, we'll move them left, right, up, and down. So there's a direct correlation from what that looks like to what you've learned the last month. So let's turn to, if you have your book, 305, page 305.
305?
Yeah. While keeping your thumb where you're at.
Oh, you know what? I have 305 bookmark.
Probably a good idea. Okay. So yesterday we translated from radians to degrees, right? So you're going to have to do a little math here. This is sine. So look at your table. If I want to know the value at 0, what's the sine of 0?
0.
Right, it's 0. So my point is 0, 0, right? So if I have an x, sine x table, what's the degree measure for pi over 2? That's pi over 2 right there. You get a nice shot of that. What's the degree measure for pi over 2? You're guessing. Use the conversion formula. Pi over 2 times 180 over pi. 90. Okay. So what's the sine of 90? I know you said it.
1.
Okay. At pi, what degree measure is that? This one should be automatic. 180. It's halfway around the circle, right? What's the sine value?
0.
0. 3 pi over 2 is 270 degrees. That value is -1. And then 2 pi is 360. The value again is 0. So what we're doing here is basically giving you coordinate points. So this is how I remember how to graph sine. I basically have little points at each of these spots. 0, 0. Pi over 2 is 1. Right? It comes back down to pi, it's 0 again. 3 pi over 2 is -1. And 2 pi again is 0. What do you think happens out here? Yeah, it repeats. It just does this again. And again and again. That's why sound waves work. You can have a tone that goes forever. It's just the same repeating wave over and over. They're periodic, is what it's called. All right, so if I were to draw a continuation of that, I would go to 5 pi over 2, 3 pi, and it would do this again. All right. And if you went backwards, it would do this again, okay? Okay, it's what we call periodic. It repeats, okay? So what's the value of sine of 5 pi over 2? 1. Yeah, look at the graph, it's 1. What's the sine at any value that's a multiple of pi? That'd be 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 0. Any of them. Okay. What about start here? 5 pi over 2, 9 pi over 2, 13 pi over 2. Those are all 1. 3 pi over 2, 7 pi over 2, 11 pi over 2. Those are all 3 and 1. If you're in degrees, all you're doing is adding 360 to everything. This would be 90. All right. 360 plus 90 is 450. Plus 360 is the next one, and on and on. You see how they repeat? They're periodic. The period of that function is 2 pi. So if it's periodic, it has a spot where it starts to repeat. In our case, sine is 2 pi. So some info here. What's the domain? Of the sine function, harking back into antiquity. The past, like 2 months ago, domain and range. Domain is the x values. So what possible x values? The real numbers. Okay. It covers every x value. What's the range? No. What does it go between? Yeah. Up and down, right? Why? It doesn't go above 1 or below 1. Hate, such a strong word.
It's quick to that one.
I know. You could think she'd be more original, though. What are the x-intercepts? We just talked about it.
Pi
Yeah.
and 3 pi and 2 pi and 0.
Yeah, pi times any n, where n is an integer. Okay, it's the repetition of pi. What's the y-intercept?
Yeah.
0, right there. What's the maximum? Yep. Thanks, Jesus. And the minimum? -1. Okay, so we already kind of talked about that. Just see. If you can memorize that graph, it gives you a lot of information.
Oh,
Okay. One last item. What is the sine of pi over 4? Since we didn't go into more fractions here, what's the sine of pi over 4? Yep. Okay. That's 45 degrees. That occurs right here. And that value is root 2 over 2. So again, we have a point. If you're on your calculator and you hit trace, when you get to pi over 4, it's going to, it's going to be a decimal. You're going to get another decimal. They're going to be equivalent to those. Okay. All right, on your calculator, what mode do we need to be in now?
radians.
Yeah, we got to be in radians mode. Okay, so you're going to have to be very cognizant on the final. When it's a degree question, which there will be some, you have to switch it to degrees. When it's a radians question, you switch it to radians. Okay? You have to be cognizant of which one you're operating. Go to the y equals.
There's a big number.
Make sure you're in radian mode. Go to y equals and type sine x. Now, graph it.
Like a worm. Like a worm. Like a worm.
Okay. Some of you are having issues with your window. Some of you can see it, and some of you can't, right? Go to Zoom. Okay, go to Zoom. No, Z standard this one. Okay, go to Z trig. The trig is going to give you the period of negative 2 pi to 2 pi. And it's going to give you 2 periods of that function. So Z trig is a good one to use with these functions. Two periods, right? Negative 2 pi to 2 pi. Your issue.
Nobody takes those classes, sucks. Yeah.
Three times.
Four times, because we're going to do homework. No, it's
Any questions on sine?
Did you know you can put annotations on YouTube?
Wow, our conversation just degraded to something worse than math.
Yeah.
Okay, cosine.
No.
No, it's close though. Okay, cosine is just sine shifted to the left pi over 2. It's called a choo-choo train. I know, right? Or Zach just, never mind. Zach, quit it. It stinks. Get it? Okay, so pi over 2, pi, 3 pi over 2, and 2 pi.
So the first thing I want you to notice is, what does that look like? Looks like sine, right? So this is sine. If you shift it, you get cosine. Just FYI. Yeah, for your information. We shifted it left pi over 2. Okay, so the same principles apply for cosine. What's the period? Yep. It repeats after 2 pi. Domain? Yep. And range? What's the range? What's the lowest? And the highest? That's that fun Greek letter epsilon. Remember that? E. It's an E. It's a Greek letter for E, epsilon. It means x is an element of the real numbers. It means any x value is a real number. Let's see. What are the x-intercepts? A little harder than the sine function. Okay, so pi over 2 is one of them. 3 pi over 2. How can we code that in general? So if I add pi, I continually hit the intercepts for x. Pi times n. So n is any integer. It can be 0, 1, 2, whatever. But the x-intercepts, pi over 2, 3 pi over 2, 5 pi over 2. What's the y-intercept? It's 1. Okay. The maximum value? 1, and the min? -1. Right. So you can see the similarities between sine and cosine, right? The period's the same, domain and range are the same, the max and the min are same. You just have some different x-intercepts and y-intercepts. So, what is the cosine of pi? Looking at the graph. -1. Okay. All right. How we doing? What? Cosine pi equals -1. Okay, I'm going to throw something at you here. Not a marker, just a math problem. My dog bit me over break.
Really? Did you whoop his butt?
No. No.
Hit you hard?
Yeah, he kind of caught under my fingernail and ripped it up. It was awesome. No. We were in an area, there were some coyote traps, and I didn't know they were there. He sniffed them out and got caught in one. So he was in a foothold coyote trap, and when I ran over there, of course, because he's yelping like a little baby, and I was trying to get him out, and I guess it probably hurt him a little bit or something, but he was panicky, and he got me. So, story of the week. Yeah, it actually looks a lot better than it did. So which function is that? Sine or cosine? Sine. Why is it sine?
Because it starts with the 1.
What are the x-intercepts? Yeah, the values of pi, did that match sine or cosine? Pi, 2 pi, 3 pi, it matched sine, right? So this is y equals sine x, okay? Okay, real quickly, just tangent. This is just informational. Where is tangent undefined? It's where cosine is 0. So where's cosine 0? Right, and? So at pi over 2, it's not going to exist. Cosine, so cosine's in the bottom if it's 0 if we're undefined. 3 pi over 2? And it's going to be back here to negative pi over 2, etc. It's going to repeat every pi. But this is what tangent looks like. Okay. Yeah, it's a little bit more funky, but it's built because it's sine over cosine. So wherever cosine is 0, it's undefined. We have a vertical asymptote. What happens as tangent approaches pi over 2 from the left? What is the y? What happens to y? So if we're approaching pi over 2 from this direction, what happens to the y value? Goes to what? Infinity. Yep. If we approach it from the right, we go to negative infinity. Okay, so we start to be able to analyze end behavior and stuff with tangent. Again, purely informational. Any questions? Bueno. Okay, 6.3, 2 through 12, 58, 60. Should be good. You have about 7 or 8 minutes. Obviously not enough time to work on the project, but I would suggest trying like 6 through 11. Those would be the good ones to start with.